Hi, my name is John DiZoglio. I'm here with fellow NetLane member Brian Newen, and we developed a new technology that's dedicated to reducing congestion and cost in public transportation systems. We're dedicated to bringing this product to market. What does our sensor do? In order to improve public transportation systems, we need to help the people that design them, civil engineers. Civil engineers make decisions based on the data that they can collect from public transportation systems. And NetLane Sensors does just that, collects data from these systems. How does it work? NetLane Sensors collects 3 different types of data: the volume of passengers on a system, as well as the speed in which they travel on the system. And key to our sensor, which makes it unique, it also collects origin and destination information. So our sensor can tell where a person gets on the system, as well as their final destination. Other things that set our sensor apart is that there's low installation costs. You don't need to dig up any roadways. You don't need to hire somebody to install it. It's a very low cost. You just put it on the bus, you put it on a pole along a roadway, and then it begins to collect data. So, what else does our sensor do? Our sensor doesn't just collect data. That wouldn't be useful to the engineers. The engineers need to see the data. We provide it in the form of a web application. How does our sensor collect data, and what makes it useful? The data that we collect is collected from users' cell phones. Any wireless device, our sensor can pick up the wireless signals that device sends out. There's a unique identifier on the cell phone that tells us how we can get from A to B. So, the web application also shows the engineers what the data is that our sensor collects. We've integrated a Google Maps API so that as the civil engineers work, they can see the route that they're currently working on. We'll also have tables that shows the data that is collected by our sensor. Who's our client? Our client is a transportation department of any size. We're looking to have a twofold business solution. We can either sell the sensors to them at a flat rate and then support them with a contract, or we can set up a contract for data acquisition over a set period of time. This allows us to aim for all different kinds of businesses and transportation departments. Let's take Boston, for example. Their transit system was developed over 150 years ago. It's slow, congested, and costly. If they were to use NetLane sensors, they can reduce wait times and cost involved for upkeep. Boston has over 150 bus lines, 5 metro stations, and 2 major train stations. If we were to put one NetLane sensor into each of these vehicles, that results in over 500 sensors sold. So, we're already working with TrafAx, which is a company that sells similar sensors, and they're very interested in the product. If you hit the slide. So, what can you do for us? We need additional sensors. In order to collect data, we need more sensors to help improve our filtering and processing algorithms. After we improve these algorithms, we'll also need a few key features that will help our sensor compete in the market. Things like solar and battery charging will help us outperform the competition. An initial investment of $5,000 will help us to reach these goals. Please help us help civil engineers improve our transportation department. I'm John DiZoglio. My team consists of 4 computer engineers and a civil engineer. We have advisors with PhDs in computer engineering as well as civil engineering. And I was wondering if there were any questions.
Can you get any of this data from something like Waves or something like that?
So the key thing that our sensor does is it's passive. We don't need the users to install an app. We don't need them to go to a website. They just enter the system, get on the bus, drive down the roadway, and we can capture their data.
So it's the only thing you really need to do is have the sensors in place.
Exactly.
How is it capturing? So if I get on a bus,
Yes.
how does it capture?
Do you have a smartphone?
I do.
Your smartphone has Wi-Fi. Wi-Fi sends out signals to try to connect to hotspots. Our sensor picks those signals up.
And what is it, what data does it pick up on?
It picks up MAC address, which is a unique identifier, as well as the signal strength, so the distance from the sensor, as well as if you're connected to a wireless hotspot already.
So it's the same way that Google's telling you right now whether there's traffic on 128.
So
Right.
no, Google uses an app that is installed on the user's cell phones. They need that app installed in order to supply that information. We don't need an app, but we need the sensors along the roadway.
So this is just saying, oh, okay, I have no idea this is Andrew, but I have a number. And it's
Exactly,
getting
yes.
on, and then it says, he just went 10 miles, it's associated with bus route 123, and so therefore it took
Right.
this long.
This number is often used in corporate, so say you walk into Kohl's, they will use that MAC address to track you where you enter the store and how you travel about. But what we do is hash this MAC address, basically encrypt it. We don't know what that number is, so that if anybody hacked our servers, stole your data, they wouldn't be able to tell that you went to Kohl's, that you went to. So it's private as well.
So are you looking at these as permanent installations so that they can, that they'll be able to monitor traffic real time all the time and
They
make
can.
changes? Or is this every couple of years or every 6 months I'm gonna survey what the traffic is like on here at different days and weeks, and I'll
So-
do it as a periodic?
Yeah. So our system can be twofold. We could sell the sensors as a unit and then support them through a contract, say they need help figuring out a broken piece of hardware or they need a new software addition to the web application. Or we can come in with our sensors, put them in the bus for 3 weeks, and then pull out after after we pull out, we'll just give them the report and say what data we collect.
John, how much does a sensor cost?
So if we can, I can break down the cost of the sensor. We're using a couple key components. The average sensor cost right now is $300. Similar sensors sell upwards of $500.
How many sensors do you need, like 4 or 3 or something, in order to like triangulate the locations? Or?
Okay, so for example, a roadway, you would put them near every exit if you wanted to see specifically how they got on and off those exits. A bus, you would put one sensor on a bus with a GPS, and then that one sensor would control where people got on and off that specific bus. So say you have 300 buses in your system, you could buy 300 sensors. Or you could just swap the sensors as needed.
So have you thought about how hard it's going to be to sell to municipalities? Or, because that sounds like who you're trying to sell to. And you kind of stole my thunder earlier, and you were talking about Kohl's, because it sounds like you could sell the same thing to like a venue or to a shopping mall, and basically say, I can pretty much tell you like the entire like circulation routes, and then you can go and ask for an increase in rent for these 5 stores because they're the primary circulation routes, you know, the next time the rent comes up. Like, it's gonna be a hard sell to like get the city of Lowell or the city of Boston, you know, to buy this. And so have you thought of going private? And maybe you've already thought of like how you're gonna sell to municipalities?
So our sensor there are sensors in the marketplace that already do, like you were talking about in Kohl's. People aren't using them for transportation systems.
So if the sensor already exists in the marketplace that can do all of this, this is take a known sensor and apply it in a different way. Why would you go build a different sensor? Why not just figure out how to market that sensor?
Those kind of sensors, though, are really, really high precision. If you want it indoors, it's difficult to obtain those MAC addresses. But when you're outdoors, it's easier to capture. So they need higher cost processors to be able to take those probe requests, what they're called, and be able to get the data they need. So that's why we have a cheaper sensor. The ones that use in store are definitely more expensive. Like I think even there's a certain range on them, up to a certain amount of feet, but.
Well, I would resist thinking that your cost, comparing your cost versus what you can buy a sensor for in the open market, if you could buy it for $500, chances are it only costs $100 to make. So don't get caught in that you're $200 cheaper. But
Is that your cost? Is that your cost, or does that $300 include margin and profit?
No, so this is a upscaled cost already. So a sensor housing normally wouldn't cost $30. anything in bulk is going to be far cheaper. These are what we purchased the components for in a small scale, one-time type thing, like Wi-Fi modules, $25 usually.
So what would you sell your product for? If it cost us $300, what would you be in the marketplace? If I wanted to buy a sensor from you, what would you charge?
About 500.
So and is that's the same 500 that's up there right now?
Right. The lowest end sensors that they sell are about 600.
So you're still coming
Yeah,
in
so,
just a little
so
bit on
there are sensors out there that will have multiple Wi-Fi modules, for example, that will sell just one channel, one module, and they can add up to 4 usually.
So the primary advantage of this over the Google traffic app there
Yep.
is,
Civil engineers don't have access to that data.
Can they buy it?
They can't.
Really?
Right.
Google won't sell it to you?
No. That's privacy concerns.
I think there's a huge opportunity here with the data itself, because it's like having sex with a porcupine trying to sell something to like the state or the municipality. Like, you know, that's 18 months or 12 months if you're lucky right there. But if you could start selling data or subscriptions to the data, so imagine you started putting this stuff out somewhere, or you got a couple of general routes, you could start selling data to civil engineers and to architects and to Spy Pond consultants down in Arlington, and this is all they do. Like, you could make a lot of money with this data. And so you may want to consider saying, hey, you get a reduced cost, you know, but we get this data. You know, if you want the data, your data set alone, and you're not going to contribute it to the common pool, then it costs you a lot of money. I think selling subscriptions to this information, it's going to be really scalable. So someone in Montreal is going to have an interest in 4 different cities, you know, similar in demographic and similar in size.
Okay.
Do you know if you need permits to put these things on poles, and
So-
what's to stop somebody from just coming by and saying, wow, this is cool technology, I'll take
$300
this home,
sensor.
you know? So, you know what I'm saying, like, how do you
Right.
deploy?
That's why we were looking for public transportation systems. So for example, the buses, they own them or they lease them.
Right.
They'll own a pole. For example, when you're driving down the road, you'll see a camera on a pole,
Yeah.
or a telephone talk box with a solar power next to it. This sensor would go on something like that, existing infrastructure.
And the one bit I didn't get is, what's so great about this for an engineer? Like, what is the engineer looking for that they can't find today? Like,
Okay,
not
so-
an engineer, so I don't
Yes,
see that.
so currently, civil engineers will sit at a corner or sit at a roadway with counters, and they will count, say, a license plate, or they'll write the license plate down, and they'll have 3 engineers on a corner trying to figure out, oh, they took this turn, they took this turn. If you have 3 guys sitting on a corner for 2 hours, that's more than the cost of a sensor already.
Don't they use those things, in the box on the side of the road with the rubber thing that you run over? Doesn't that count, like how many cars go through an intersection?
Yeah, but the major part is origin and destination. I mean, we can get volume from like, oh, at stop A, like 100 people got on it, at stop C, like 30 people got off. But we want to know exactly who the people who got on a certain stop got off where. Those kind of patterns, like if every day we have the same person get on at stop A and get off at stop 3, we can differentiate the passengers based on their MAC addresses.
So, two things. One is, I think there's a pretty big differentiation between mass transit and measuring where people are waiting and where people are getting on and getting off versus city traffic and where cars are going from here to there. If it's where cars are going from here to there, I think one thing that you might look into is selling to utilities. The utilities own the power lines and the poles. And every intersection that you go to NSTAR or something, and they own it, they buy the device, plug it in there, and they could sell the data to a variety of different folks. That's one thing. But if it's mostly, if your goal is about people getting on and off subway trains or buses, then I think you're stuck with the municipality owning the infrastructure, and you'd have to sell to them.
Okay.
Okay, all right, thank you very much.
Thank you.
Thank you.
Thank you.